Hello, everybody, and welcome to episode 26 of I Wish You Were Dead, a podcast about things that used to be alive. My name is Mike, and that is Gavin. Gavin, how are you feeling today?
I am pretty good, Mike. I am just hanging out. I had a pretty good weekend, I'll say.
I,
What
I
about
might
you?
say it was.
How was your weekend?
I might say that it was outstanding. Our weekend because we got to hang out both virtually and in person, and it was going back to our roots. Gavin, you've mentioned a couple times on the podcast before, but you and I met volunteering for this youth leadership seminar, and we had it for the first time in 2 years yesterday,
We
or
did.
this
Of course,
past
it
weekend.
was
This past weekend is what I should say.
right. It was all virtual, as most things are these days. Um, Even though I feel like at least a good majority of our staff is vaccinated. We had to like make the decision for it to be virtual back in like February at the latest. Um, so like obviously it was going to be virtual. If it's not in person next year, I am going to be so upset.
I mean, if it's not in person next year, I can only imagine what that means for the state of the planet.
Right?
There would
Yeah.
have to be a new pandemic or something for it not to be in person next year. I would have to think.
Yeah. Um,
So,
but
but
then
yeah,
afterward, after we were done with the weekend, we were with the students on Friday and Saturday. Um, us and some friends who live in the vicinity, sort of that we do. We have friends from like all over the state, but for anyone who didn't want to drive more than like 2 hours, it was pretty much just a handful of us, and we all got together and hung out and had a couple adult beverages, as people do when they reunite after not seeing each other for like 2 years. Um, and it was a wonderful time.
it really was. It was one of those things that you didn't know how much you missed it until it was taken away. And so being able to see all of you guys, Gavin, you included, was just it made my weekend. It truly did.
Absolutely.
So we have a king sized episode today, which I'm really looking forward to. So let's quickly get to we can get to our this week in science right after we take care of some housekeeping. Once again, you guys can follow us on Twitter. Gavin, what is our podcast handle on Twitter?
At Dead Podcast _ on Twitter.
You can follow us right there on Twitter, where Gavin's been posting some really cool things, just about science in general. Gavin, do you want to talk a little bit about some things you've posted?
Yeah, absolutely. So I have mostly just been retweeting some like, current practicing scientists that I think only like a couple of them I've met. Most of them I'm just like aware of them. Um there was a really cool study and it was completely open access. So if you want to read the entire study, you can go, which we talked about. What episode was that? Let me find it. Um we talked about sort of the I think the episode was titled "The Publishing Industrial Complex," about how papers get published, how academic journals sort of work. In episode 14, we talk about how all that works. But this was an open access article, so anybody could read it, regardless of if you are affiliated with a college or university or not. So that is on my Twitter, and it's basically some really interesting like genetic stuff about the species of cow that like we domesticated, the cows that we all know and love and most people eat these days. Um, so it's the species that we domesticated that from. Some genetics things about that species, which I thought was kind of neat.
Yeah, and there's a lot more where that came from. So you guys can follow us once again. What is the podcast handle, Gavin?
At Dead Podcast _
At Dead Podcast _. In addition to that, you can keep up with Gavin on his blog, and Gavin's blog is it deepdigs.net?
It sure is, Mike. I've not posted anything to it in a while. I've been a little busy, but it will be up and running again soon. But in the meantime, I do have 3 articles up there. A couple of the topics that we have talked about before on the podcast, but if you want to get to know me just a little better and sort of my writing style, feel free to check that out as well.
And it's going to be one of those things. I imagine there'll be more content as the summer approaches, and it's a great place to either expand on things we've talked about here, or as I see you've talked about here with Field Camp Reimagined after COVID-19, which we've certainly talked about on this podcast,
Mm-hmm.
as well as some things that just don't quite fit into a podcast medium, or at least haven't yet. We haven't quite had a chance to record an episode along those lines. So that's a great place to check out once every couple of days, see what's new there. And then in addition to that, we've also got a couple of forms you can fill out. We've got a form where if you or someone you know would be a good guest on the show, if have an area of expertise in something sciencey, you can fill that out because we would love to have you on the show. And then there's also a form for specific topics. If there's something in the field of, paleontology or geology, uh, or just something broadly science related, feel free to fill out that topic form, and we will do our damnedest to cover it in an upcoming episode. We want to hear from you guys. We want to make sure that we are, I guess we're populists at heart. Uh, and we definitely want to make sure that you guys have as much a role in the creation of this podcast as possible.
Absolutely. And honestly, if it's up to me, I'm honestly probably just going to resort back to doing episodes similar to this, where I just like pick a group of animals and talk about them, which I'm sure people like. But like, uh, some groups of animals are much more popular to regular people than they are to me. Like, there's a reason why I did lizards before this episode, even though I feel like elephants are objectively more interesting to most people than lizards are. But to me, lizards are just such an interesting group of animals. Also, because of I'd say more than half of like extinct reptiles have the phrase saurus or soar in their name somewhere, but are not lizards. That's why we talked about lizards. But today we're talking about a much more charismatic and well-known group of animals.
Which you have given away. We were talking about elephants today. So I know it's a little bit longer on housekeeping than we normally spend, but I definitely wanted to take some time to just go through kind of all the different things that we have going on, different ways that you can interact with us, and different ways that you can help us improve the show and take part in the show yourself.
Absolutely. Couldn't have said it better myself.
Links for everything that we just talked about will be down in the description. And now I think we can move on with the show. So, Gavin, this week in history, things have been moving back the last couple of years. So I'm going to take a guess and say the year we're looking at is 2014.
Not quite. 2018.
Yeah, I didn't even get it. You're close on that.
Not even close. No.
No. All right. All right, 2018. Tell me what was going on in 2018.
So I will say, looking at through this entire week, including both weekends, the weekend that we just had as well as this coming weekend, none of them were really at all geology or biology related, so I really didn't have much to choose from. Well, this one is from June 10th. So tomorrow, if you're listening to this the day it comes out. But from June 10th, 2018, pillars of creation rely on magnetism for structure. I read that and I was like, I don't know what those are, but sure, I guess.
Pillars of creation rely on magnetism for structure.
Yes, and as they do sort of explain what the pillars of creation are. They're not like some philosophical thing. It is like the name of a feature in space.
That sounded like a religious thing more than philosophical.
No, nope.
Okay.
It's out in space, but it says a team of astronomers using data and images provided by the Hubble Space Telescope proposed that the cosmic gas clouds known as the pillars of creation may get their shapes and their name from strong magnetic forces running through the structures. The pillars, located in the Eagle Nebula, some 7,000 light years from Earth, are surrounded by a massive plasma, which exerts inward pressure on the structure. Scientists say that by studying light waves released from the pillars, they have traced the directionality of magnetic forces within the pillars, which equalize pressure exerted by the encircling plasma clouds. The team hopes that their research may help future studies better understand the role of magnetic forces in the process of star formation.
Most of that was over my head, but I'll tell you what, it sounded really awesome.
Long story short, so plasma, I guess I'm guessing they're called pillars because they are like elongated in shape, I would assume.
Mm-hmm.
But basically, they're mostly made out of plasma, which most people kind of learn that there's only like 3 phases of matter, that there's like solid, liquid, and gas. But if you like super heat gas, it turns into plasma, which is what stars are made out of. And so But when things are really hot, they tend to bounce around a bit more. So if you, for example, if you blow up a balloon
Right.
at room temperature and then you put it in the freezer, it will shrink
Yes.
because the air molecules are moving faster and bouncing off the outside of the balloon much more quickly with much more force when they're warm than when they're cold. Similar thing where plasma, if just a gas can change that much from that bit of temperature, when it gets to the plasma state, it does that to the extreme. So I'm guessing that it maintains these elongated forms because of some form of magnetism that is happening that these people discovered.
That makes actually a little bit more sense. And the magnetism is able to, to keep things in line in a way that it wouldn't otherwise exist. Um, I remember one time I was on Reddit a couple of years ago, and one of the top posts was like "new phase of matter discovered" or "new state of matter discovered," and I was like, "Really? Like that's a thing?" And then I went to the Wikipedia article for like states of matter, and
Hmm.
I was like, "Oh my goodness, there is way more than just solid liquids and gases."
Oh yeah, absolutely.
It
And I
is.
don't pretend to understand almost any of them. Like I barely
Nope.
actually understand like what plasma is. I don't know how it works other than I know it exists and it's real hot. That's about it.
It was one of those things where it was like, half of these only exist for, some fraction of a second at a time, but
Yeah.
they still count.
Yeah. I mean that's how physics works, I guess.
We should do an episode on other planets geology or whatever the term is for that. I'm not sure that's in your wheelhouse, but that'd be fun for
I can look into it.
what
I
is
mean, there
Mars?
is
What is Mars like?
well, it's cold on one side and hot on the other, and it's pretty red,
Kind of
and that's
dusty.
about it.
Okay,
Got a couple robots on it right now, so
that's pretty cool.
yeah.
We should count that as life.
Anywho, let's get into it.
Let's
So,
do it.
we are talking about elephants, more specifically, their cousins, as well as them. Because not everything that's big and has a trunk and tusks is an elephant. But before we get into any of that mumbo jumbo, what is an elephant to you, Mike?
Yeah, this is gonna be one I think I'm gonna struggle with. Um,
Okay.
right. So if I was to define an elephant, the one of the I think defining characteristics is just their size. But I think I've heard at one point there are like smaller evidence, or like there is a species and maybe it's extinct of like what are classified as elephants that are much smaller than I would normally think.
But
But I'll
just
put that
just in your everyday life, if
right.
you had to give your own definition of what is an elephant, even just the ones living today, what would it be?
Right. You bring a 4-year-old to the zoo and they point and they're like, "What's that? Big kitty." So I'll say animals that are huge, like the size of a small house. They've got a hairy tail. They have tusks. They've got a long trunk that they use to, I believe, both like breathe and like collect food and water, or at least like use it to funnel into their
Mm-hmm.
mouth.
Right.
Right. They are mammals, so they give live birth, and I believe the gestational period for elephants is
Mm-hmm.
like a year and a half or so.
I
I don't
think it's
know.
closer to 2 years.
Yeah, okay, closer to 2 years. Um, yeah, it is definitely another one of those things where you kind of where you know it when you see it, and there's not a whole lot
Right.
else that exists on the planet today that like could easily be, at least I think, that could easily be confused for an elephant. So it's just kind of that bare bones,
Mm-hmm.
really big thing with the tusk and tail. You know, you've got that, and you've got like the old school, the representations of woolly mammoths. So that's kind of
Okay.
what comes to my mind is just really, really large mammal with the tusks and tail, um, you know, that give live birth and such
Mm-hmm.
and such. So I don't know exactly how I did on this one. I don't know if this is one of those ones. I know this is one of those ones that like, yeah, that kind of fits, or this is one of those ones where it's actually we're gonna bust this wide open.
We're gonna bust it wide open.
Okay, so
So
let's
well
break this
the
down.
biggest thing with there are three big things with elephants. At least the currently living ones, but that generally apply to most of their extinct relatives too. Number one is their size. They are real big.
Okay.
There are obviously exceptions, which we'll talk about a bit. Number two is tusks. They are very, very famous for their tusks. They're obviously not the only animals with tusks, but that is one of like the biggest defining features, and that's one of the easiest ways to tell different groups of these animals apart from one another as fossils. And then probably the most defining feature, which is how they get the name of the entire group, the like group above elephants, is their trunk. No other animal, from what we can tell, ever has had anything even close to an elephant's trunk. We have some animals that have really flexible upper lips, or relatively small trunks. There's a relative of horses and rhinos called tapirs that basically look like a pig with like a big, fleshy, like little tiny baby trunk. Um, but that's kind of it when it comes to trunks, other than elephants, where it's like, a tapir has like a 6 inch or so trunk. Elephant trunks are like 6 feet long, and there's really nothing in between. um,
I never considered that, but the more I'm thinking about it, like I'm not I'm thinking of like underwater sea creatures, and like I just Googled an anteater, and that's it's not even close. Like,
that's its entire
yeah, a
face. That's
trunk,
not a trunk. That's
right?
its skull.
Yeah, like that's like I was trying to think of anything else that has a trunk, and until you just said that, like it didn't kick in. But yeah, what other animals have a trunk have that feature? Like I got nothing.
Yeah, no, there's really nothing close, which is why the name of the larger group that includes elephants is called Proboscidea, which the I believe it's Greek. Actually, I have the Wikipedia page open. Fun fact. Um, Comes from the Latin. Okay, I wasn't sure if it was Latin or Greek. I think Greek has a form of it too, but basically the word like proboscis, meaning nose. Pretty sure that's what that means.
Okay.
Um, yes, it is generally when you hear that in like a biological sense, it just means like an elongated feature on the face of an animal. So, like for example, like a butterfly's little sucker mouth that it uses to like sip nectar from, that's also called a proboscis. But in elephants, you always just hear it called a trunk. So those are the three most easily definable things for an elephant. Um, so elephants are real weird in that if you kind of look around the animal kingdom, at least today, there's nothing else that really looks like them. We think about other big mammals like that. You think of like rhinos, which don't really look like them. Like they also have like a big dangerous horn, but it's not even close to the same. Um, and then things like hippos, which are also not really all that similar. There's nothing really close to elephants. So, what would you say if you had to take a stab, just off the top of your head? What are elephants' closest relatives?
Elephants' closest relatives, so they're mammals. So that,
Mm-hmm.
I would say that narrows it down, but I'm not really sure it does. Um,
The
God,
answer will
close.
surprise you, I promise.
So this came to my head before you said that, and so I'm just gonna throw this out there.
Mm-hmm.
We mentioned on one of our last episodes. I don't know if it was our last one or something before that. Um, it had to have been one before our last episode. That whales were also mammals. So
Mm-hmm.
I'm gonna take a shot in the dark here and say a whale.
No.
Okay.
So whales are most closely related to hippos.
Okay. So I wasn't
You're
super
not
far
far
off.
off with the aquatic thing though, because the closest living relatives to elephants are dugongs and manatees.
Really?
Yep. Which kind of makes sense. They're like big, kind of gray, kind of plump. Um, manatees also have a very like flexible upper lip that they use to eat seaweed and things like that. So like if you like know my manatee biology, it kind of makes some more sense. However, their next closest living relatives make absolutely no sense unless you have seen their skeletons and things. And even then, it still doesn't make a ton of sense. But those two are pretty closely related. And then their next closest relatives are a group of animals called hyraxes, which,
I'm
if you
not
look at
familiar.
one, yeah, they're exclusive to, at least these days, to like Southern Africa. Um, they basically kind of look like a gopher or kind of like a rabbit with much shorter ears.
Yeah, I was gonna say like a squirrel that's let itself go.
Yeah, that's a good description. But so they go from these giant tusked things, and one of their closest living relatives is like this little rat guy, which just goes to show elephants are weird. Everything we're going to talk about today is just about how weird and cool elephants are. Um, but so let's talk about what elephants are kind of around today. There are currently two different genera, the plural of genus, that total make up three species of elephants. So there's the African bush elephant, the big one that you typically think of with the big floppy ears that you always see on like savannas and things. That is Loxodonta africana. That is the largest living land mammal. There's another species in that genus.
Really, really quick before we go any
Yeah,
further, when you say largest living, is that like mass? Is that volume? Is that height? Is it like what do you mean when you say largest living land mammal?
typically mass is what
Okay.
that means. Um, Almost always, it's at least throughout history, it's also the tallest, although giraffes are technically taller than elephants. They're not
Hmm.
nearly as heavy. So for the sake of this episode, when I say large, I mean heavy.
Okay.
Um, but yeah, so that is the African bush elephant, what most people think of as when they think of elephant. There is also another species in that genus called Loxodonta cyclotis, which is the African forest elephant, much smaller, about half the size, but still an elephant and still big. It's still like 6 to 7 feet tall at the shoulder, as opposed to the more typical elephant, which is closer to like 12 or so feet tall at the shoulder.
Hmm.
And then you have your Asian elephants, which are in the genus Elephas. There's a single species of them alive today. It's Elephas maximus, as well as there's a handful of subspecies for that as well. But there's broadly three species of elephants alive today, and they only live on two continents. That is absolutely not the case for previous elephants. Um, and I also want to talk about some of the things that also make elephants weird, just to give you a real sense of, even for like weird mammals, they are so heckin' weird. Like we're kind of used to them because it's like one of the first animals that you kind of learned about, just because they're big and they're neat. It also helps that they're really smart. Um, but compared to anything else, they are so incredibly weird. So
Okay.
um, we'll talk about their trunks first. So their trunks are sort of like a fusion of their nose and their upper lip. And other than your tongue, or the tongues of animals, they are pretty much the only skeletal muscle features that I am aware of that is not like directly connected to a bone. So there are three different types of muscles. There's cardiac muscle, which is only found in your heart. Smooth muscle, which is basically sort of your digestive system and your diaphragm, that makes you breathe. Basically, muscles that work without you thinking about working them.
Right.
And then there's skeletal muscle, which is used for basically everything else. Um, so elephants do not have a bone in their trunk. That is pure muscle all the way down. And so um, when the muscles work, normally muscles work. Yeah, if you think of like your biceps or triceps, they pull on ligaments that are attached to bones, and then they move whatever bone they're supposed to move. The muscles in an elephant's trunk pull on each other, which is why it can be so flexible and have such fine motor control. Like elephants can like pick up eggs without breaking them, and then also rip trees out of the ground using just their trunk. It is one of the weirdest and coolest things that have ever evolved. It's so
Th-
weird.
this falls into the category of things that, again, makes sense when you say it, but like I guess I never considered it. But like, yeah, we've all seen elephants. We've been to zoos and things and seen elephants, you know, doing their thing, and
Hmm.
they're whipping it around and moving it in a bunch of ways. And yeah, of course, like Now, just you saying that, of course, there's no bone there. Because it couldn't. How could you do the things that it does?
Like, what bone would that even be?
Yeah,
Like,
right.
thinking of me as, like, someone who knows anatomy, what bone could that even be?
Answer. It's not.
Yeah, exactly.
Yeah, right. But muscles pulling on muscles. I would love to have this kind of goes with our, if you are or someone that is, an expert on things. I would love to have some expert on, elephant anatomy or just like, body, a muscle person in general, just to explain how that works because it seems so foreign to anything that I would be used to understanding.
And, like, obviously there is, it's attached to its skull somewhere, but if it's
Of course,
just like the action of just like pinching the end of it, the little grabby part at the end of its trunk,
right?
it's not like there's a bone there for that to act on. And like, now that I'm kind of thinking about it, I guess your lips kind of do a similar thing, which makes sense for an elephant too. But um,
It
yeah,
makes sense, except for my lips aren't, 6 feet away from the nearest bone.
exactly. Their tusks are also real weird. Like I said, they're not the only animals with tusks, but they are weird. Um, so tusks, as you probably assumed, are teeth, but they're weird teeth. Um, in elephants specifically, they are the second incisor, so not the tooth like your two front teeth. They're the ones next to that between your front teeth and your canines
Hmm.
that just stretch right out, and they are ever growing. Your teeth stop growing after a while. Elephant tusks do not. They permanently grow all the time. Um, and also, just the rest of their teeth are real weird too, because unlike most mammals, not all of them, but most have just the two sets, like humans do, where you have your baby teeth, those fall out, and you have your adult teeth.
Hmm.
And then there's some animals like sharks and crocodilians, where you pull one out and one kind of grows in its place relatively quickly. Elephants kind of do a bit of both, in that they have 12 sets of teeth, but they only have one at a time. Well, I guess four at a time, one on each side, upper left, upper right, lower right.
Okay.
And so they grow, they use them until they wear down, and then they fall out, and another one comes in and takes its place. And they have 12 sets throughout their life that they use. So they
So
only
they,
have one big tooth on each, like, sort of side of their mouth at a time.
and they can go through, there's, kind of the four corners of your mouth. They
Hmm.
basically can go through like, four sets on each side.
No, they have 12 sets on each side.
Oh, I thought you said that it was kind of like divided up into the four sections. Okay. Wow.
No, so they have, at least this is what uh, okay, I think I might have written this wrong in the script actually. So I think they actually have six sets. So they have three baby and three adult. So I think like on each like half
Hmm.
they have 12, but in each like quarter. So like your upper right, they have three baby molars and then three adult molars.
And what causes them to change over? Is it just time? Is it like,
It's just
eventually
that
the
that's just how it happens to be. There's really no difference between them other than that the adult ones are bigger.
gotcha. Okay.
Um, and then lastly, elephants have many adaptations that are good at helping them be big. But one of the weird ones is their feet, which like makes sense because that's how they carry their weight. But you would think that they want to be big and they want to be stable, so they'd want like a really flat foot, which it kind of looks like they have.
I thought they
However,
did.
their feet are much more similar to like a cat's foot, where they're sort of walking on their toes, than ours, where their entire sort of heel is on the ground. But they do a weird special thing in that they put this big old pad in the middle of what their like palm would be. So essentially, it's as if you had like a tennis ball in your palm that just stayed there the whole time, but you put most of your weight on your toes instead of like the actual flat part of your hand, and then the tennis ball acted as like a cushion to support whatever force you put on it.
Hmm.
So, like I said, everything about elephants is just super weird.
I am beginning to understand now.
So Now let's get into a little bit of like their diversity in the past, because even though there's only 3 species, if you want to talk about like subspecies, arguably 6 total, um, but anywhere from 3 to 6 species around today. They were very diverse in the past. There's at least, from what I could find, about 200 or so species that we know of, and some of them did not look very elephanty at all. So the first ones that is for sure in this group of proboscideans is from 58 million years ago, from the Paleocene epoch, which, 58 million years ago, that's not very long after the end Cretaceous mass extinction that killed all the dinosaurs.
I was thinking there was something that happened right
Mhm.
before then.
Yeah. So around this time, it was right about 58 or so million years ago. So about 8 to 10 million years after the extinction is when life really started to pick back up again after the extinction. Um, and it was at this time where, all of the big scary dinosaurs, because they weren't around, mammals could diversify into all the weird various forms that we see today, plus tons of super weird old ones too, um, including the proboscideans. So the first, for sure, proboscidean that I was able to find is called Phosphatherium from Morocco, so like northern Africa. And if you looked at it, you would not say that that's an elephant at all. It would look much more like a pig, probably, without the hooves. Because it's only like large house cat to like foxish sized.
So they started off being reasonably small,
Mm-hmm.
which begs the question. I know we talked, and you might be getting to this later on. I know we talked about this, and I think our one of our dinosaur episodes, or maybe something else, but just how hard it is for animals to get to a certain size.
Mm-hmm.
And elephants, being, as you said, the largest land mammals, like I assume that there's some benefit to that, but there's also got to be some considerable drawback to being just that obscenely massive.
We absolutely will talk about that.
I figured as much.
But yeah, so they were really small, and you would, even like when you start looking at its anatomy, you're like, why? What is this? Because its teeth, it did not have the weird teeth yet, where they only had one at a time. They had teeth that were pretty not, specialized at all for much of anything. They looked a lot like pig teeth, because at this point, we're pretty sure they were still probably omnivorous, eating things like insects as well as plants. Um, but they didn't have a really much semblance of a trunk at all, actually, because elephant faces are pretty flat, at least when you look at their skull. Um,
Hmm.
and these guys were still pretty had quite a bit of like a muzzle to them. Um, it's kind of debatable whether they had tusks. If they technically were tusks, because the main thing with a tusk is that it is ever growing, and it's difficult to tell that always. Sometimes with when they're kind of on the borderline. So if they were technically tusks, they were just these little itty bitty little baby ones that probably didn't even stick out of its mouth. Um, and so that was, like I said, just giving like sort of the baseline of what this is what elephants started as, like a little house cat size thing that would look much more like a pig or a tapir than it would today's elephants. And there were lots of similar things kind of running around at the time that are closely related, but this is sort of the earliest one. The first time that we see tusks, though, is from much later, from an animal called Barytherium from Egypt from around 33 or so million years ago, um, toward the end of the Eocene epoch and the start of the Oligocene epoch.
Is this the
Much
first time we
shorter.
see tusks?
Yep.
I'm sorry to interrupt. Is this the first time
Yeah.
we see tusks, like just in elephants or things that would become elephants, or is this the first time we see tusks? Period. Like were rhinos having tusks, before this, or were rhinos even a thing at this point?
I don't believe rhinos existed yet, although I don't know much about like the origins of rhinos. Um, Rhinos also barely have tusks. Their two bottom incisors kind of count, but sort of not really. Um, Hippos probably had tusks by this point, but I don't know that for sure. Um, Pigs probably had tusks by this point too, but specifically, the first time we see tusks in proboscideans was with this animal.
Okay.
Um, Still, relative to today's elephants, very short, but we're getting kind of bigger, around 6 feet or so at the shoulder. So probably about cow sized, maybe a little smaller. Still, probably not really a trunk. Its tusks were still pretty short, much more similar to like hippo tusks than elephant tusks. Um, and weight wise, it was just a little over 2 tons, so somewhere around like 4,500 pounds or so. So a big animal for sure. Definitely not the biggest animal around at the time, and really not that big for like a modern elephant today.
Mm-hmm.
But this is the first time that they sort of start to get a little bigger. And again, there were lots of other closely related things running around at the same time. This is the earliest one where we see what we are pretty sure are like legit tusks. Then we get to the late Oligocene, around 25 million years ago, and we see a bit of like a decline in their diversity. And then stuff gets absolutely crazy. Because right around this time, as we sort of mentioned in our episode about the South American or the Great American Biotic Interchange, where episode 16, where North America and South America crashed into each other, Africa broke off from South America quite a while ago. And in that episode, we talked quite a bit about how South America was alone for a while. Africa was also alone for quite a while, not nearly as long, but for a while, which is why we see some of the oddest animals being in Africa. Obviously, we still have things we see everywhere else, like cats, dogs, but some of like the weird animals are also found in Africa. And around 25 million years ago or so is when Africa hit into Asia and Europe, and then things got real crazy. So, now we're going to talk about things that actually look like elephants. Like, you would see it and you'd be like, that's a real friggin' weird elephant, but you would at least see it and know that it is in that group.
I'm curious as to why they look weird, and I assume we're going to get there.
Oh, we sure are. Because elephants, or I should say proboscideans, while they are named for their trunk, because fossils, and as we talked about, the trunk has no bones. We typically do not get anything of the trunk preserved. There is one exception, which we'll talk about toward the end. But for everything I'm about to talk about, except for that one exception, we don't really know what their trunk looked like. So I want to preface this with that.
Okay.
But their tusks get real crazy. So for this first group that we're going to talk about, this is one of the older groups that is sort of the closest relative of... It's technically still in the same group as the last one that we talked about, the Barytherium. That was like, it's like elephant adjacent.
Mm-hmm.
It still had a long trunk, but it does not have big upper tusks. Instead, it's got some weird lower tusks, because that's actually very common in elephant relatives to have tusks on the bottom jaw too.
Okay.
So, this first group are called the Dinotheres, which means the terrible beasts. And they deserve it because they were really big. They were a bit bigger than like African elephants today. Not a ton bigger, but still very large. And so they sort of came around in like the middle to late Oligocene. And they had backwards chin tusks.
Backwards chin tusks?
Yes. So
What is
instead
that?
of having tusks like a normal elephant that come out of their top jaw and sort of go out away from the face, they did not have any upper tusks. Instead, those same incisors on the bottom jaw. So not the front ones, but the ones next to those. Those got real big and turned into tusks. And instead of going out, they recurve down the chin like a goatee and kind of come back toward the body.
That's awesome, but
Mm-hmm.
that
And for a long time,
can I Google these and see either like an actual picture
absolutely you
or
can. I
artist
encourage you
representation?
to because they are so weird.
What am I
And
Googling one more time?
Dinotherium. It's spelled with an E though, so Deino.
Notherym. I don't know how this is
I
spelled.
IUM.
All right. Oh my god, look at that.
It
So
basically, and they're big tusks too. Like they're not super long, but they're chonky.
look, wow. I'm gonna put a link to just like when I Google image when I Google image search this.
Mm-hmm.
I'm just gonna put a link to the Google image page, and the people at home can take a look for themselves because wow, that look. I
They
like.
are weird.
I would be afraid I would like stab myself in the throat if I had those things.
So, well, for the initial thought when people first discovered them was that they were used for digging. I don't know why anyone would ever reasonably think that, personally, because like like I said, they're not super long, so it would have to basically be on like its elbows to dig at all. What we're pretty sure it used them for now is like scraping bark off of trees.
What would be the purpose of that?
I mean, some things eat tree bark, like beavers eat tree bark. That's almost exclusively what they eat, actually. Um,
Okay.
yeah, because like the pulp of the tree is on the other side of the bark, and if you can scrape the bark off, then you can get to like the actual kind of nutritious part of the tree.
Okay. I guess that makes sense.
Yeah. Um, so yeah, they were real weird, but other than that, and a couple other things with their teeth, they had very different. They actually had at this point the more traditional elephant teeth of like the phrase that's used for those like replacing teeth are called marching molars, which I love. So they did have the marching molars, but they were shaped differently than what we see in modern elephants, which we'll talk more about elephant, like the actual shape of them in a little bit here. Um, but so they're elephant lineage adjacent, not quite. I think the technical name for the group is elephantiforms. So they were, even though they are very much the shape of elephants, they are not actually elephantiforms, which is the actual name of the group.
hmm
But once we get into that group, we get some more familiar sounding things to people. So, have you ever heard of a mastodon?
I have heard of mastodon. Yes, in my head that's really similar to a woolly mammoth.
And in most other people's heads, that is also the case. However, they are not.
Okay.
So that just goes to show, sort of, once you get to this point in elephants, they all look very elephant-y.
Okay.
So everything from here on, with a couple notable exceptions, which I'll mention, look very much like an elephant. But so next we have mastodons. They're sort of the most sort of primitive, even though I don't really like using that word, but the least derived elephantiform. So they have really weird teeth for elephants. Almost everything else we're going to talk about have relatively flat teeth, mostly because they ate things like grass. And as we talk about with horses, having flat teeth is good for eating grass. However, with horses, they solve the problem by just making their teeth really tall. Elephants were just like, I'm just going to have more teeth. Um, uh, yeah. So, but mastodons have very spiky teeth, and they're used mostly for eating things like shrubs and less sort of tough, gritty plant material. And it's funny. So these are all in the family Mammutidae, and most of them are in at least the American ones. The New World ones are in the genus Mammut.
hmm
So mastodon itself is not an actual term in science. Everyone knows what you mean, but that's not like the name of a genus or anything. Um, because Mammut was proposed first and accepted first, and then they found some of the ones here, and were like, I'm going to come up with the new genus Mastodon, which technically means Breast tooth, because the person who named them thought that the spikes looked like nipples for some reason. However, it was later realized before he actually could publish it that the specimens that he was calling mastodon or proposing to be called mastodon were actually already described in a genus called mammut, which is why mammut is the actual technical term, but mastodon is much more fun sounding, and that's what stuck with regular people.
Okay.
They're also much stouter than other elephants. They had shorter legs and generally just not as tall. Still really big, but not as tall.
Mm-hmm.
Very, very widespread. And the ones from North America are much more common and much more studied. However, pretty much all of these, even the dinotheres, kind of got around a bit. At least globally, they're mostly known from Africa, but the dinotheres were also sort of known from like Asia, India. Mastodons are on every continent besides. I don't think they got to South America, and then no proboscideans ever got to Australia or Antarctica. But they were very common in like Africa, Eurasia, and North America. And it's a lot easier to get around those long distances and walk those long distances when you're so big, just because you just kind of move faster.
Makes sense. Yeah, longer legs.
Right. And it's like an elephant, it just makes more sense, can walk a longer distance in a day than like a mouse, which is why these things were able to become so widespread, which is really cool.
Mm-hmm.
So the next, and probably the weirdest ones that we're going to talk about for the rest of this, are called the gomphotheres, which
By
are...
the way, just some outstanding names in
Oh,
this
yeah,
episode.
absolutely. So, yeah, these are colloquially called the shovel tuskers.
Shovel tuskers.
Yes.
Time to do another
And,
Google.
yep, so they have real long... So their upper tusks are not all that long. They're relatively short and sort of downward curved. Their bottom tusks, and not just the tusks, but their entire chin, is real long. And this, obviously varies from species to species. But there are some of them, for example, and this isn't actually a gomphothere, it's somewhat closely related, but it's a genus called Platybelodon, where their chin, like the end of... And so it's not just the tusk, it's the actual like bone of their jaw extends like a couple feet past their upper jaw.
For the record, I Google imaged this and I'm immediately including this in the show notes because this is also just really weird
They're
looking.
so weird.
It. How,
So
where's their mouth? Like I see their chin there, but like the. Oh, my goodness.
So the best way that I've found to describe this group is, before we started recording, I asked Mike if he had seen the show that most people around our age probably have, but The Fairly Odd Parents.
To which I answered yes.
This is essentially the Crimson Chin, where his chin in the show extends like a solid foot past like his actual face. Scale that up to elephant sized, and that's kind of what we're dealing with here, except the chin has teeth on the end of it.
So really quickly here, the Crimson Chin, for those of you that aren't familiar, was a superhero-like character in the animated TV show The Fairly Odd Parents, with just like this cartoonishly long. I mean, it's literally a cartoon, but even for a cartoon, a cartoonishly long chin that extends out. The equivalent of like I don't know, a foot and a half.
Yeah.
And that's a perfect description of these guys because they're again their bottom tusks and chin go out like again looking at the representations here, we think of like tusks almost, or pardon me, like trunks almost like a nose, which I don't believe is entirely inaccurate, but this one almost looks like
it's a fused upper lip and nose.
this looks like the trunk and then the chin are like like
About the
almost
same
one
length.
Yeah, like they're almost one mouth working together. Like that's the top part, and that's there's a top part and a bottom part. The trunk is the top part. It's a little bit shorter of a trunk, I think, and then you've got the bottom, uh, the bottom chin thing, and it looks like they're
Hmm.
functioning together. This is nuts.
Yeah, and so they're called shovel tuskers because the bottom tusks are very broad and very flat, like the end of a shovel, and we're pretty sure. So if you were to just Google Gomphothir, you'll probably get lots of results of them living in like a swamp or something, or eating some kind of aquatic vegetation. That's the old school like sort of thought of it. That's not really what we think anymore.
Okay.
And also you'll probably get lots of images of their trunk being relatively short and kind of wide, right, to cover their big, massive chin.
Mm-hmm.
As I said earlier, um, we don't know what their trunk looks like. We have no idea. So it's
And that's important to keep in mind is that this is all artist representations and
right. And I think it's kind of leaning more toward the thought that like they had sort of like an extra almost set of lips so that they could close their mouth. So it's not like their trunk was against this big giant chin acting as its upper lip too. So like it could close its mouth with its trunk not against its like chin.
which is even more strange.
Right. Um but the sort of modern consensus is that it used these, well, I should say they, because there's many species that are like this. Um but they use their tusk at the bottom on their chin to cut grass. That they would sort of grab some tall grass with their trunk and then sort of move their head from left to right and use that as like a scythe to cut grass that they would then eat.
Mm-hmm.
That's mostly what we're pretty sure they were using it for, although it is pretty hard to tell. So that's these guys. Their teeth are also kind of weird. They're much flatter and more like modern elephant teeth than the mastodon teeth are. Um, but they're still not quite elephant teeth. Then we get to the closest group of relatives to modern elephants called stegodons.
Stegodons, that's a fun name.
Yep, that means roof tooth. Not quite sure why. I think that just kind of sounded good.
It does.
It does. So these are also known much more commonly called, or at least like colloquially, like kind of nickname as like straight tusked elephants. Um, so they have, as the name suggests, very long, very straight tusks. Where you think of modern elephant tusks, they kind of curve outward and then sort of curve back in. These don't do the curve outward, and they're basically just sticking down like a 45-ish angle from the face, completely straight. And in one genus, they don't have a gap between them. They're basically right together in the middle of the face, coming out straight.
Hmm.
And you're probably thinking, or may or may not be thinking, hey, isn't there something that's supposed to go in between those teeth?
Right.
Like a trunk?
Right.
So, we're pretty sure that they must have held their trunk off to the side. Because, frankly, I don't think it would make sense for their trunk to be longer, because these tusks could be like 10 feet long. So, like, having a trunk long enough to like reach in front of it probably wasn't, even though we don't know much of anything about their trunks, we're pretty confident in saying that just doesn't make too much sense. So they would have to hold it off to the side and go around the tusks in order to scoop like food into their mouth under the tusks.
That seems bad. That seems like Charles Darwin screwed something up there with these animals.
Well, they we're pretty sure they were using it for like defense, and it's like, well, if you're just using it to joust, I mean,
Oh yeah, you know what? At that point,
so, and like
yeah.
they weren't perfectly straight, but they were kind of like downward curved and then curved back up, but they didn't curve out.
Hmm.
But they, yeah, and like that didn't happen until later life. Like the younger ones, obviously, before their tusks could get that long, still looked almost essentially like baby elephants. Um, but yeah, they would just have to sort of reach around it, and it was like if your trunk is long enough to do that, what are you out? You know.
Right.
But now, if you just have a long jousting pole sticking out of your face, and you can still eat and drink properly, what's the problem?
I see no problem at all.
So those are the stegodons are the closest relatives, at least like group wise, to true elephants in the family Elephantidae.
And correct me if I'm wrong, each species of elephant that you've mentioned to this point is extinct now.
Yes, not even the species, the entire groups. So there are no dinotheres left. There are no mastodons left. There are no gomphotheres left. They're all gone. Though, as we'll
Okay.
talk about, much more recently than you might think.
Hmm. I well, go ahead. I thought I remember something, but you go ahead and keep
No,
going.
go ahead.
And
Hit me.
I it was going to be something, and I don't remember exactly what it was, but going back to like mammoths, like
Hmm.
I thought that mammoths were still around when it was like the pyramids of Giza or something were being built, or something that like like there's human history being recorded while also these things we think of just being extinct forever. We're still walking around the planet.
Oh, I will absolutely talk about that
Oh, okay, perfect.
in just a minute here. So, none of these things that I've talked about so far, even though you would point at it and say, that's a weird, funky looking elephant, have not actually been elephants. True elephants are in the family Elephantidae, which is what we're going to talk about now. So, this includes the two genera of current elephant that we have, that we talked about at the beginning, the mammoths, as well as probably the largest land animal or land mammal ever, called Paleoloxodon. And here I want to get on a little bit of a soapbox.
I'm gonna shut the hell right up. You go ahead.
So, most people think of dinosaurs as these really large, like terrifyingly large things. And that's kind of because some of them were. Like, some of them were obviously, on average, very, very large. However, people really don't realize that some of them were actually relatively small, or smaller than you would probably guess. So, modern African elephants, the African bush elephant that we talked about earlier, the largest current land animal today, is almost exactly the same like height and weight as a triceratops. But most people would probably, if you had to say which one is bigger, I feel like 9 people out of 10 would say triceratops just because dinosaurs are so hyped up that they're gigantic and terrifying. Um, and then we get into some of the largest of these proboscideans, like Paleoloxodon, who outweighed a good chunk of sauropod dinosaurs, the big, long neck dinosaurs. So, for example, Paleoloxodon was at the shoulder about 17 feet tall, over 5 meters, and weighed about 24 tons. This is a massive friggin' animal. You could walk underneath its belly, and the average person probably would not hit their head.
I I know you said this was your chance to get in a soapbox, but 24 tons?
Mm-hmm. Which, for example, is and granted, it is very hard to give weight estimates for things where we only have their bones. But,
Even if it's half of that,
well, so half of that is a large African elephant.
which is still massive.
But so 22 tons is almost twice some well known long necked dinosaurs, such as Diplodocus and Apatosaurus, some of the smaller species in those genera, and also taller. So like mammals are cool too. It's not just dinosaurs.
Yeah.
So Paleoloxodon would essentially just look like a gigantic elephant. Its ears would probably be quite a bit smaller than like an African elephant's, but it would look almost exactly the same. Their tusks are also a lot straighter and obviously quite a bit longer because it's just such a larger animal. And
Hmm.
this is, we're pretty sure, there's a couple others that kind of give it a run for its money, but a probably the largest land mammal ever. Huge, huge, huge animal. So, with that, we can move on to the mammoths. And mammoths are neat because they're not like a separate group from modern elephants. They're more closely related to each other, or to the Asian elephant, than the Asian elephant is to the African elephant.
Hmm.
And it's not just like by the bones that we know that, because we actually have a full mammoth genome, as we have talked about in episode 7 about Pleistocene rewilding. We
Right.
have the complete mammoth DNA. So we know from DNA that its closest relatives were Indian elephants or Asian elephants. And uh, this is also a little bit of a soapboxy thing, not nearly as much, but not all mammoths were woolly.
Oh, really?
Mammoths are really cool. There's like 5 or 6 species of mammoths,
Huh.
and only one of them is the woolly mammoth.
Okay.
So mammoths are distinct from most other elephants in that their tusks are much more curved. Even the non-woolly ones had very uh, curved tusks, so they'd kind of go out and then curve back in, and then be curved like back toward the face a bit. We're really not sure exactly what they used them for, because if the point, the tip of it is kind of pointed back toward your face almost,
Hmm.
you're not really stabbing things with it like you would kind of think. What we kind of think they were using it for was, at least the woolly ones, the non-woolly ones who didn't live in, super cold climates, we kind of don't know. But it's been proposed that they kind of used it as a shovel so that they could dig through the snow to get at grass and plant stuff underneath the snow. But again, that only works for woolly mammoths
Hmm.
because,
Good
for
snow.
example,
Right.
the largest species of mammoth is called the Columbian mammoth, and that gives Paleoloxodon a run for its money in terms of size. It's probably a little smaller, but right up there. And if it had hair, it would probably be relatively short. You would probably just see that and be like, "Wow, that elephant's really big and has got some weird tusks." But like, it wouldn't likely have been, uh, really too much different than a regular elephant in terms of like how much hair it's got on its body.
Right.
And so that concludes our sort of walk through elephant diversity. But one last thing that I wanted to touch on with elephants is that they've been around much, much more recently than a lot of people think. Because, like you said, it's kind of like a fun like party knowledge piece that like technically mammoths were still around when the pyramids were built, and that is true with an asterisk. There was a dwarf species that was living on an island near Siberia when the pyramids were being built, like 4,000 years ago or so.
Hmm.
The full size ones were not around. We're pretty sure they died around 10,000 years ago.
Okay, but like, when we say a dwarf size, like how big?
Um, Probably around. Let me actually look because I don't know that off the top of my head. Um, so there's the pygmy mammoth, which is the species Mammuthus exilis, because it is an island mammoth.
Hmm.
Um, let's see. So it was between 5 and 6 feet tall, like at the shoulder or so, and a little less than a ton, 1,600 pounds or so.
Mm-hmm.
Which compared to, because that particular species is a direct ancestor of the Columbian mammoth, which is 14 feet tall at the shoulder and about 20,000 pounds. So islands do some funky things. And that's what I was trying to get at a little bit earlier when you were saying there's a real cost benefit to being that big. Obviously, the benefit is that, sans humans with spears and things, the only thing that can really kill an adult proboscidean is another adult proboscidean.
Right. Like, there's not. Well, is that true? Like, what about like a lion?
Lions have to be really desperate to attack a full grown elephant, like a healthy one anyway.
Hmm. Okay.
Like a pride of lions can, if they tried to attack like a healthy male,
Right.
they probably would not be able to do it.
Really?
Well, because think about it.
Wow.
One hit from the trunk would probably kill a lion. They can just straight up rip trees out of the ground with it.
I
And
never.
and
I guess
elephants are smart enough to be able to throw things, so like it could probably just straight up pick up a lion and just chuck it.
I never considered an elephant's tusk that strong on its own, but yet like with the dexterity that they have, like we talked about, if they're that strong, then yeah, I guess that makes some amount of sense. Like, not to say it couldn't happen, but just
So
based on that, yeah, I'd
mhm.
probably take an elephant 8 times out of 10 in that fight.
Yeah. And so like obviously that's the benefit. Being so big just makes it way harder for anything to try and eat you. And then because elephants are smart enough to have like social dynamics and like a herd, being big protects your babies when they are young and
Right.
small. So that is probably the biggest benefit. Plus, it also does allow you to travel much farther, like I kind of talked about, which is a really big thing when it comes to water in places like Africa. At least like sub-Saharan Africa, where like African bush elephants live, water can be kind of hard to come by. So being able to travel long distances fairly quickly allows you to travel from water spot to water spot to water spot much more quickly and efficiently. Um, However, as I sort of talked about also in the flight episode, where talk about how flight is very costly, and how I sort of talked about how birds have gotten rid of the ability to fly many times because flying is very costly. There are many, 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 many species of like island dwarf elephants. There's like I think 2 or 3 species of dwarf mammoths, several species of like dwarf stegodons, dwarf gomphotheres, dwarf mastodons. Every one of these groups that we've talked about, at least from like dinotheres on, there is at least 1 or 2 island dwarf species.
That's so wild and awesome. Like,
Mm-hmm.
I love that just the like an island existing and these animals being on an island can cause such a dramatic shift in the size of these animals. Like, that's for me, that's one of the coolest things that we know about evolution and biology.
Well, so elephants are actually like really good swimmers as well.
What? They're good swimmers too?
Mm-hmm.
Oh my god.
They're very good at swimming, and it helps because they can just like keep the tip of their trunk above the water, and they can breathe. So it's basically like a
They're
snorkel.
scuba diving. Like, god.
Yeah, and they're buoyant enough that they don't just straight up sink. Um, like hippos. Hippos don't swim. They are so dense that they sink and run along the bottom of the river or lake or whatever. Fun fact. Not important, but I like that fact. Uh,
I'd call it important. That's amazing.
but elephants float. So
Elephants
they are
float.
shockingly
Can,
good swimmers, and
can that
like
be the title of this episode? Elephants float.
I'd prefer it wasn't, but it's
Okay,
fun. It's a fun fact.
it's a great fact.
Um, but yeah, so like they're even today, like Asian elephants especially are really well known to just kind of go. They're like, hey, I see an island out there. I can probably swim to that, and then they do. And so, like for example, some of the potential subspecies of the Asian elephants are from islands. A couple of them. Um, so that happened a lot. And while yeah, the elephants could swim back, or more elephants could swim to that island, but if you just have a couple generations where they just kind of don't, there's limited resources on an island, which would just in general make that elephant smaller. You're eating less food, you're not going to grow as much. So children, eat your vegetables if you want to be big and strong. Um, yeah, so they just don't grow as big. And then over generation and generation, that continues to happen until you get a pygmy elephant. And yeah, so elephants are just sort of in closing. I'd say other than bats, because bats can fly and that's super weird. Elephants are probably like the weirdest, at least mammals, probably ever. Because we have
And it's
everything from what we think of today that everyone's familiar with. Everyone knows what an elephant is and can picture one in their mind. But they just take so many weird tweaks, like having weird backwards goatee made out of tusk, or a chin that goes out 5 feet from your face. And I
they're
love it.
sneaky weird because, like you said, everyone like there's a familiarity with elephants. It's not one of these animals that you'll hear about on National Geographic or the Discovery Channel, and you've never heard of it and it looks strange and you're like, oh my god, I can't believe that Earth has that to offer. Like you said, everybody knows about elephants, and yet just over the course of the last hour plus, like just thinking about all the different ways that not only elephants of today are strange, but also like the proto elephants that have gotten us to this point. Like I would you would know better than I would just how strange they are, in general, but just the strangeness over familiarity factor. If there was
Mm-hmm.
some division problem you could create, or some unit of how strange an animal is, versus how familiar and normal it seems,
Mm-hmm.
just because of how often we see them. Like I can't think anything else comes even close to an elephant.
No, like there really isn't. Like I said, other than bats, just because they're super weird. Maybe some of like the aquatic ones, like whales. Dugongs also were quite weird. Dugongs and manatees are also quite weird. But like, there's nothing as weird in as weird of ways as an elephant, and I love that so much. Like it also really helps, how much we know about them because they're so big. Big things preserve as fossils much better than small things. And so I guess that's an added benefit to paleontology, uh, for them being big as well. Um, and one more follow up that I need to do because I mentioned it a couple times. The one exception to which one of these whose trunk we actually do know what it was like
Oh yeah, please.
is woolly mammoths. That is the only one that we actually know because we have frozen mammoths.
So correct me if I'm wrong, like they're not fossilized in a normal way. They're like frozen in time, literally.
Right, yeah, they are frozen in permafrost in like peat bogs, typically in Siberia, although there have been some found in like Alaska and northern Canada as well. But almost exclusively the frozen like mummified type ones are from Siberia. And that's mostly where we have like the complete woolly mammoth genome from. As well as because we have multiple, they're typically babies that we have completely frozen, but I think there's a handful of adults. that we have found like fully intact frozen. So that is the only one that whose trunk we actually know what it looks like. And but because it's so close to elephants, mammoths, like I said, are elephants' closest relatives. Uh, it doesn't really help us because like, well, we already know what an elephant trunk looks like. It'd
Hmm.
help if we somehow had like a frozen mastodon. That would help, but we don't. Um, but yeah. So anyway, I wanted to follow up on that, and I kind of forgot to. But
No, that's awesome, man. I mean, does that bring us to the conclusion of the elephant episode?
I think it does. I don't really have too much else to say, but just from beginning to end, from their closest relatives being dugongs and manatees, and also weird rabbit, squirrel, fat things, going all the way through to being these super cool, powerful, super smart too. Like I didn't talk much about that just because you don't get that in the fossils. Elephants are so smart. Um, is just so cool and wacky and incredible to me.
And that is, I think, where we are going to leave it. So, once again, take a look at the description or the just the links down below in this episode to learn more about anything we talked about, or to again look at those things we talked about in the beginning of the episode. And this has been episode 26 of I Wish You Were Dead, a podcast about things that used to be alive. This has been the elephant episode. My name is Mike. That is Gavin. Gavin, this kind of blew my mind, but thank you for preparing this episode for us.
Of course, buddy. I just love elephants so much. Bye, everybody.
I love them more now too. Goodbye.